Hello everyone. Today I will present my final paper for this course, Automated Test Case Generation and Defect Detection with Gen AI. LLM is the topic of the paper. Particularly large language models like LLM, GPT 2, 3, 4. These are revolutionizing the software testing domain. Our focus will be on automating test case generation and defect detection for AI-based system in this presentation. This is specifically relevant to the AI systems as they grow more complex and critical in various domains. The aim of this presentation is to explore these advancements in AI and their implication in the software testing. Here is a quick overview what we will cover today. We will start by identifying the challenges in testing AI-based system, followed by exploration of how generative AI addresses these challenges. We will then dive deep into the research objective and proposed framework. We'll discuss the evaluation of the results and conclude with framework strength, limitation, and potential direction, and a quick demo of the framework. Right. So we'll start with introduction. Why automated testing? Automated testing has become a necessity in the modern software development lifecycle, particularly for AI-based systems. The growing complexity and adoption of the AI is in critical applications. It demands for robust testing framework. Traditional manual methods are not only time-consuming, but also prone to human error. Automation, by contrast with LLM, ensures that testing is both efficient and consistent, particularly when integrated with the modern AI methodology and technologies. For this research, for this paper, I reviewed several other papers as well. Some key papers are here, if you see on the screen. Papers like Spahu et al. 2020 and Arcuri 2008, they focused on automated testing and how AI can enhance the generation of test cases. Whereas other papers like Summerstreet 2015 and same Spahu et al. In 2022, they offer a good insight into testing adaptive AI models like LLMs. Arcuri and Yao in 2008 and Gottfried et al. In 2005, they explores the effectiveness of the co-evolutionary and random testing methods. Sumsri also covers the impact of the AI-generated bugs on current testing framework and addresses the issue of scalability when testing large AI models. So before we deep dive into essential all it's necessary to understand some key concept. So we'll start with generative AI. Generative AI refers to models which are capable of generating content such as text or images. Large language model LLMs are AI models trained on very vast data sets to generate human-like language such as ChatGPT or Mistral or Gemini from Google. Automated testing is a use of the tools to automatically test software functionality. And co-evolutionary approach is a method where both bugs and systems are evolved simultaneously, improving bug fixing process over the time of the system develop evolves when the system is evolving as well. So there are challenges in testing AI-based system. They present unique challenges basically. For instances, non-deterministic behavior, which means that the same input might produce different results, making traditional deterministic testing ineffective. Moreover, many AI models such as deep learning network are black boxes, meaning their decision-making processes are opaque. These systems are also heavily reliant on the quality and diversity of their training data, which makes the testing dependent on comprehensive data set. Existing tools often lack the capability to handle such AI-specific issues. So the role of the generative AI in the software testing were specifically LLM, such as GPT-3 and GPT-4 and other GPT models and LLM models. They have revolutionized the software testing. Their ability to understand and generate code, simulate complex user interactions, and predict fault in the system makes them ideal for addressing the challenges in the AI system by automating test case generation and automated defect identification. They significantly enhance testing and efficiency and accuracy of the testing. The primary objective of this research are threefold. First, to create a comprehensive framework that leverages the power of LLM for automated testing. Second, to tailor a test case generation specifically for a complexities inherent in AI system, tailor a LLM. And third is to compare and demonstrate the superior effectiveness of the framework against conventional testing methods. The proposed framework, which I'm proposing here in this presentation, is built on three key components. First, by selecting and fine-tuning an advanced LLM, such as GPT, I'm using GPT-2 for my paper, on a data set that are specific to AI system and test case generation. And for this, I'll be using a Kaggle data set to train my model. Second is to include specialized modules for input processing and test case generation. Finally, the framework incorporates advanced systems for defect identification, leveraging contextual understanding of the LLM and their capabilities. So the input processing stage for the framework, which is like a very crucial for ensuring that the LLM receives well-structured and meaningful data as input. The AI model's metadata parser extracts the key detail about the AI system, such as its architecture, the hyperparameter used in the AI for training, and also the data preprocessor. It standardized the diverse input type, including text, images, and structured data. A dynamic context injection enhances the LLM's performance by providing additional contextual information such as API documentation, etc. The test case generation phase of the framework utilizes the advanced algorithm, which are primarily search-based software engineering methods or technique. These includes evolutionary algorithms to create test cases and structured prompt. They are basically from the structured prompt for the LLM. And each generated test case undergoes semantic checks such as buildability check that ensures the test case is synthetically correct and integrates with the system. Execution reliability check verifies that the test consistently passes under the repeated execution. Coverage improvement algorithms. These measures line and branch coverage to identify and prioritize impactful test cases. This multi-step validation process, powered by these specialized algorithms, ensures that only high quality and reliable test cases are retained. And detection of the defect is another critical component of this framework. Regression testing retains the re-executes the existing test cases to prevent functional regressions. Dynamic behavior analysis monitor the AI model output under various scenarios, to flag anomalies. Finally, debugging tools leverages the LLM to identify the root cause of the issue, providing actionable insight. So the data preparation of the LLM, for that we use the data as we mentioned, we have a Kaggle data set, the link is here. And we'll also see in the demo, which has 977 functional and non-functional requirement and test prompts. And the steps taken in the data pre-processing are data cleaning, data augmentation. Also, we use the data augmentation to balance the underrepresented class and structuring the data fine-tuning. If you see the screen here, we have type of data called suppose SE, which is kind of security and functional requirement and functional test, all that. Against that, we have the requirement all in the data set that we are using to train our framework. Fine-tuning the LLM. So to fine-tune the LLM, certain training parameters and matrices are used. The LLM was fine-tuned using specific training parameters such as small batch sizes and smaller learning rate. Basically, the smaller batch size and smaller learning rate. This helps to achieve a gradual but stable learning. Metrics like training and validation loss were used to and monitored to ensure effective learning without any overfitting in the model. Evaluation metrics, the key metrics that are used are precision, recall, and F1. As we all know, precision is basically accuracy of defect detection. So evaluation metrics provide a quantitative insight into the framework and its performance. And precision measures how accurately defects are detected, while recall assesses how comprehensively defects are identified. Whereas the F1 score balances these two matrices, and the defect identification is efficiency reflects the time and resource saving achieved through the framework. Result and insights. Improvement in the defect detection accuracy is a primary result we found. The results highlights that the framework's significant improvement in accuracy and efficiency. Many other paper that I was talking about, they have already recorded that through this LLMs we can achieve 50% accurate improvement in the accuracy. Manual effort was reduced significantly, and the framework demonstrated scalability, making it suitable for complex AI systems. Whereas if you compare with the traditional testing, with this framework, traditional testing methods rely heavily on the manual effort and struggles with unique complexities of the AI system. In contrast, the LLM-based framework automates key processes, adapts to if dynamic behavior of the AI system and scale effectively. So future work and future direction for this research can be expand the data set with a more diverse example to improve the model robustness, integrating hybrid approaches for better accuracy, improving the hybrid approaches combining with AI and more rule-based model. That can be another approach, and exploring domain-specific fine-tuning to cater the specific application and train the model to the specific domain-related specialized field. In conclusion, we can say that LLM-based framework provides a transformative solution for testing AI systems while creating the test case and a defect identification and addressing AI systems' unique challenges and enhancing efficiency, accuracy, and scalability. Now we will get into a system demo where we'll talk about or see the system, how it is created. So I'll take you to first to the code where I have used the data directly from the Kaggle, if you see my screen. And I have different type of data labeled under functional requirement, availability, fault tolerance, legal is L, look and feel is LF, maintainability is MN. Likewise, we have securities as SC, usability as US, and non-functional requirement as NFR. After getting the data from Kaggle, unzipping it and all that, we did all the data pre-processing. Here we are checking the data detail and insight, and we are doing all the data balancing and augmentation here and checking whether after augmentation data looks good. I found it okay. And then we moved on. We used the GPT-2 tokenizer and model here. And We are training this here again with our new training parameters on the data and saving the data into our custom folder. After training with 100 epochs, batch size of 2 and a lower learning rate as we see here, we are able to train the model and validate here. And we have the confusion matrix and all the accuracy here showing up. How this graph, like training loss, it shows how the training focused and it reduced the loss gradually. And by the time it reaches the steps, we have a very good um, eh, loss, like the loss is reduced consistently, and it can see that training is consistently improving. After that, with evaluation, we also see that trend date model is performing good on the evaluation data. And after that, we can conclude with some testing. And if you see that I'm testing it and the system is generating the output, I took this train model and created a small app so that the user can access it from the front end. So this is same test case generation LLM PY using the same model here. I just created a front end on an app. So if I run this code with a library on Python called Streamlight, it generates and opens it runs on the local host right now. I have not deployed anywhere, and it opens up and shows the app. So like you see, app is launching here, which has LLM and my train data, and this is a front end. Here you can see that this is a application which leverages generative AI to generate test script and identify potential defects. I have categorized this front end into multiple bullet point. I'm using pure Python here to make sure that all the prompts are going to generate what is being given. So there is a one for generate test case, another one is to generate defect, another one is to generate both test case and defect. So if we take both test case and defect and we try to see what model does, we can type in the model should maybe let's take something like simple. A user should be able to reset password of AI system by sending email. Or yeah, that should be okay. I send an email. So why want a test case generation about ability of the user to reset password for the AI system using email? And I'll click the generate. I'm expecting that system should generate a test case, categorize within the labels that we trained it on. So if you see this, I have a test script generated. It says, okay, navigate to the forgot password page and put email address and all these steps. And system is also, if you see, categorizing potential defects here. You see, if I increase the size. So the potential defect can be forgot password page not accessible, email address input field is not accessing valid email addresses. So these are the potential defects. And if you see the label, it says security. If I want to just generate the test case and I can clear it and I don't want to generate anything like a defect, I can say able to run AI model in batch. If I want a test case for this, my test case generation should be relevant to this. And if I go and wait for model to generate the output, so it generates an output. Here it is giving me the test case ID and generating, we verify that AI model can run in batch. Precondition, the functional AI model is available, sufficient data for batch processing is available, required hardware and software setup is complete. And then it says all the steps and expected result and post conditions. And these are the test case generated, and it is operational category here if you see, as against the SC security in the previous test case. So with this, we can say that AI models are able to perform and generate my test cases. And now if you see, these are the paper which I used for, which are for references. And there are more, but I just mentioned here in the presentation a few. And yeah, we are open for question and answer. Feel free to write me back for questions and answers. Thank you so much.